Here we go. This is day 107. This is graphing logarithmic equations. Here is the objective. You're going to graph logarithmic equations. Okay, you need to know how to do it by hand. But once you know how to do it by hand, where can you always go to check your work or graph anything? Desmos or a graphing calculator. Some people have like really nice, big, legit ones. Or you can use Desmos, which is pretty legit also. And it's free. Go Desmos. Okay, so what I'd like you to do is, if you're on the video, please write this down. Okay? So today what we're going to talk about is... Uh-oh. Got stuck. So what we're going to talk about is the relationship between exponential equations and logarithmic ones. So remember that they are inverses, that we switch the x's and the y's. Exponential equations or functions are inverses of logarithm functions, okay? Inverses, you all remember that? Yes? Okay, cool. So let's just do a little reflecting. How do you make this a logarithmic equation up here? 2 to the third is equal to 8. This is exponential equation. How do you make the logarithmic? Uh-huh. Base what? Uh-huh.
Big 8
uh-huh.
equals 3.
Equals 3. Good. Okay, log base 2 of 8 equals 3. Do you all agree? Yep, that's right. Very good. Okay? So, well, what happens if we have like 2 to the x is equal to y? Okay? Let's just change this to a function. Okay? This could be any ingredient, any input. We're going to get an output. Okay? So, if I make an xy table here, okay, and I put some ingredients in, right? Okay, let's go through this. What's 2 to the 0? Say I put 0 into here. What's 2 to the 0, everyone? 1. Good. All right. What is 2 to the first? 2. 2 to the second? 2 to the third? 8, right? And I could do this forever. You know, I could make a graph of all my inputs and outputs, and this is a function of the exponent, right? And notice that it gets bigger as you're getting bigger, as the x's are getting bigger. It's getting exponentially larger, right? Does that make sense so far? Okay. So now I want to convert this to a logarithm. Eyes up here. How would you write this as a logarithm? Remember how over here you converted this to a logarithm? How would you write this as a logarithm?
Log 2 y equals x.
Y equals what? X, right? Would y'all agree with that? Good. Now, remember what I said about logarithms and exponential equations? What are we supposed to do with them? Switch the what?
X and y.
X and y. So I'm not going to keep x and y up here. I'm going to switch x and y. So it says log base 2 of x is equal to y. Okay? And now I'm going to take this and make an xy table here. Okay? So watch carefully how I do this. I'm going to put in ingredients for x, and then you're going to tell me what the outputs are, okay? So I'm going to put these ingredients for x. Okay? Ready? I'm going to put a 1 in here. 2 to what power is equal to 1? What? 0, that's right. Not 2, not 1, but 0, right? 2 to what power is 1? 0, right? Okay. Log base 2 of 2 is what? 1, good. Log base 2 of 4 is 2, and log base 2 of 8 is what? 3, right? Do you see a pattern here? Now, do you kids notice the exponential version and you compare it to the logarithmic? What do you notice that's similar and different? Turn your neighbors really quick. Go. 10 seconds. Okay, what did y'all notice? They're all flipped, right? Okay. So that's because exponential equations are inverses of logarithmic equations, okay? So we have to know how to do the exponential equation. We learned this a few weeks ago. Now we're going to do this, and we're going to connect it, okay? So here we go. If you're in the video, you need to write down the steps. Please pause the video and write the steps down. Okay, here we go. So you should have written down the steps. All right, numbers 1 and 2. I'm only going to show you 2 problems because this is kind of, it takes a long time. And I'd rather you spend more time practicing than for me just to show you how to do it. So we got identify the domain and range of each, and then sketch the graph. Okay, so I'm going to sketch the graph here. So I can't really like graph this easily without changing this to an exponential equation. So remember what I said about exponential and logarithmic equations? They are what? Inverses. Are you okay? Sorry. Are you okay? Okay. So it's okay. Things happen. So we know they're inverses, right? So that means the x's and y's we need to switch for our logarithm and exponential. So the first thing, eyes up here on number 1, we're going to switch x and y. So it's going to be x is equal to the common log of, and we're going to change our x to be a y minus 1, all plus 3. That's the first step. And why don't you kids work alongside with me? That way we can work this out together, okay? So the next thing we're going to do is we need to convert this to a exponential equation. So I need to isolate the logarithm. So I'm going to subtract 3 on both sides. So it's going to be x minus 3 is equal to the common log of y minus 1. And then just like before, we're going to convert this into a... Okay, we're going to convert this into an exponential equation. So you should write 10, because that's the base of our log. 10 to the x minus 3 is equal to y minus 1, right? And then we're going to add 1 to both sides. So we got 10 to the x minus 3 plus 1 is equal to y. Do you all understand how I converted that into an exponential equation? Yes? Give me a thumbs up if that made sense. Thumbs down if you need me to repeat it again. We don't have a middle thumb.
I do.
We only have thumbs up or thumbs down. Thumbs down means you need to go through it again. Okay. One more time. Converted my y to an x to y. Move the 3 over here, subtract the 3. This is isolated, so this is log base 10 of y minus 1 is equal to x minus 3. I converted this into an exponential. We have a base of 10. So the x minus 3 is equal to y minus 1. And then I added 1. Okay? Good. All right, so now we're going to do what we did earlier. We're going to make an xy table. Okay? So remember how we graph exponential equations? So we have to think about the exponent here. How do I make my exponent x minus 3 equal to 0?
Careful.
How do you make x minus 3 equal to 0? What would you set x equal to?
1.
No. 0 minus 3 is equal to negative 3.
3.
Oh, 3. Good. So 3 minus 3 is? 0. So we want to set our first x equal to 3, okay? Because watch what happens. What's 3 minus 3?
0.
What's 10 to the 0?
1.
1. Good. 1 plus 1 is? 2. So our output when we have 3 should be 2, okay? Good job, Sadala. Okay? Then we're going to pick 2 x's that are bigger than 3. What are 2 numbers that are bigger than 3? 4 and 5. Okay? And we're going to put those in also. Okay, here we go. What's 4 minus 3? 1. Okay, 10 to the 1 power is? 10. 10 plus 1 is? 11. So when I have an input of 4, I get an output of 11, right? Now we're going to do 5 here. Here we go. What's 5 minus 3? 2. 10 to the 2 power is? 100. 100 plus 1 is? 101, right? So this is an ordered pair, 5, 101. Now, do I have 101 boxes on this particular graph? No, but we know it could go on forever in that direction. Okay, next I'm going to pick 2 smaller numbers in x. We got 2 and 1. And here we go. If I put 2 in, here we go. What's 2 minus 3? What's 10 to the negative 1?
No solution.
No. What's 10 to the 1?
Imaginary.
Okay, 10. Okay, what's 10 to the negative 1? Nope. 1/10. Good. Okay, what's 1/10 plus 1?
1 and 1/10.
Excellent. 1 and 1/10. Good. This isn't a trick question. You got it. Okay, keep going here. Next one. 1. What's 1 minus 3? Negative 2. What's 10 to the negative 2? 1 negative.
That's going to be 10.
Okay, remember, let's take a step back. 10 to the negative 1 is 1/10. 10 to the negative 2 is?
1/100.
Good, 1/100. Okay, does that make sense? What's 1/100 plus 1?
2/100.
No, 1/100. 1 whole plus 1/100 is 1 and 100. Okay, does it make sense?
Yes.
And let's just predict. What would 0 be? 1 and what?
0.
We're going good. 1 and 1,000. That's right. Which is an even smaller fraction. What would 10 to the 4th be, or negative 4th? It'd be 1 and 10,000. Right? Does that make sense? Okay, good. Now remember what I said. This is the exponential equation here. Okay, we're almost done. Almost done. This is the exponential equation. What do we know about the relationship between exponential and logarithmic equations? They're the what? Inverse, right? Which means we switch the x and y. Remember how we have the original equation? What kind of graph was it? Logarithm. I'm pointing at it. Logarithm. Thank you. Y'all good? So isn't this exponential the inverse of the logarithm? Yes? So shouldn't I, remember I switched x and y? This is x and y here, so watch what I'm going to do. These are the x's and y's for this exponential equation, but I actually want the logarithmic equation. So I'm going to switch them back. Watch, I'm going to just cross out the x and write y, and cross out the y and write x. And these are my ordered pairs, okay? Make sense? Okay, so now watch what happens up here. Since this is my x, I'm going to go to 1 and 100 and go up 1. So I'm going over 1 and 100 and up 1. And there should be a point right there. Okay? See? And then I go to the next one. 1 and 110, 2. We're going to go 1 and 110 and up 2. There should be a point right here. Boom. Okay? Then we got 2, 3. We're going to go over 2, up 3. Okay? And then I'm going to go over 4, up 11. Oh, no, not 4 or 11. I have to think backwards. Over 11, up 4. So I'm going to go over, it only goes to 8, so I have to count. 9, 10, 11, 12, or 11. Right here. Maybe? I don't know. It's off the graph, right? But I know it's going to go off the graph in that direction very quickly. And then you said that 0 would have been 1 in 1,000. So if I went 0, or 1 in 1,000 to 0, there would be a point here, right? Well, there's my graph, and that's it. And of course, what can I do to check my work at the very end? Desmos. Okay? Very good. So, make sure that you know how to do this by hand. Okay, that's just number 1. Okay, that took a while because I was explaining. The next one I'm going to go more quickly through. Okay, any questions on number 1? Any questions? That takes a while, right? But the big idea is switch it to exponential, graph it, or figure out the exponential point, flip it back, and graph it. Okay? Okay. Michael, please bring me your phone. Okay, so number 2. Number 2. We got y is equal to the common log of x minus 1 all plus 1. Thank you, sir. Okay, so, good. Flip the x and y. So everyone's doing this with me. Everyone, raise your hand if you need me to give you just a little bit of time to catch up. Okay, good. So here we go. Number 2, we're going to flip the x and the y. Flipping the x and the y. So we're going to say x is equal to a common log of y minus 1 all plus 1. Then I want to isolate the log, so I'm going to subtract 1 on both sides. So we have x minus 1 is equal to the common log of y minus 1. And now we could convert it back to, or into an exponential equation. So we got 10 to the x minus 1 is equal to y minus 1. And then I'm going to add 1 to both sides. So 10 to the x minus 1 plus 1 is equal to y. Okay? I just did everything that I would have done on number 1. Okay? Nothing new. Just different numbers. Okay? Then I'm going to make my xy table. I'm going to pretend like I'm going to graph this. Okay? I have to ask myself, what do I need to do to make my exponent equal to 0 here? What do I need to do to make it equal to 0? what should x be first?
1.
1, right? Because 1 minus 1 is 0, right? When I put 1 in, I get 2, right? Because 1 minus 1 is 0. 10 to the 0 is 1. 1 plus 1 is 2. Okay, then I get to pick two larger numbers from 1. Let's pick 2 and 3. And we're going to put those in when I put in 2. 2 minus 1 is 1. 10 to the first is 10. Plus 1 is 11. And when I put in 3, I'm going to get 101. Hey, look at that. What do you notice about these numbers? 2, 11, and 101. Don't they look very similar to here? Yeah. That's because these numbers are very similar. Don't assume that it's always the same, but they sometimes turn out this way. Okay, now we're going to pick two smaller numbers than 1. We're going to pick 0 and negative 1. And when I put in 0, it's 0 minus 1 is negative 1. 10 to the negative 1 is 1/10. 1/10 plus 1 is 1 and 1/10. And then we get 1 and 100th here. Okay, so this was the exponential graph. Are we graphing an exponential equation?
No.
No, we're graphing a logarithmic. So we have to turn it, turn the x's and y's back to y's and x's respectively. And then we're plotting these points and graphing. Okay? And that's your answer. Does that make sense, everyone? Okay. Got 2. I think Sedella was first, and then, yeah.
What's the point of switching values?
The point of it is so that you could graph it by hand, because you can't really know what the output is unless you know what your inputs are. Does that make sense? Yes, Christian.
On the x and y chart, number 1, shouldn't that be 1? Because when you plug it into...
On this one?
Yeah, shouldn't that be 1?
Okay, let's go. 1 minus 1 is?
0.
What's 10 to the 0?
1. Oh, okay.
Okay. Very good. All right, so I'm not going to go through, these problems take a while, right?
So for negative 1, is that 1 and 100?
Uh-huh.
Okay, I get it.
Yeah, 1 and 100, that's right. Okay, so I'm not going to go through a bunch of problems because I think you just need to practice it, okay? So I assigned an AM to you. That concludes the lesson, by the way.